Welcome. Good morning, good afternoon, good evening. My name is Kristen Beck. I'm a computational biologist at IBM Research. And today I'm excited to kick off the first ISCB Academy Industry Seminar Series with Sam Westreich, who comes from DNA Nexus. Today, Dr. Westreich is going to speak about the development of Precision Fda, a bioinformatics portal that demonstrates how we can bring the advantages of cloud computing to biology and genetics. Dr. Westreich received his PhD in integrative genetics and genomics from the University of California, Davis, focusing on bioinformatics methods for the microbiome. At DNA Nexus, he helped develop cloud-based microbiome applications, and he now serves as the program manager in charge of the Precision Fda portal development, working closely with FDA reviewers and scientists. We're excited to hear about the Precision Fda platform today. And during the seminar, if you'd like, feel free to post any questions in the Q&A. If they're immediately relevant, Sam will try to triage those as they come, and we can handle questions at the end. Also, this talk will be posted on YouTube afterwards if you'd like to share this with your colleagues and lab mates. And if there's anybody else who you'd like to see showcased in this industry series, please feel free to reach out to myself, and I'll drop my email into the chat as well. So without further ado, Sam, it's all yours.
Great. Thank you so much. Thank you, Kristen. So hello, everyone. I'm excited to be here today giving this talk and discussing data transfer analysis and how we drive community challenge solutions through this Precision Fda platform. So let me just start by going over briefly the points I want to hit. So today, I want to just briefly share the creation and the goals behind Precision Fda, the methods by which Precision Fda helps foster FDA engagement and community engagement through a number of different methods. I do want to briefly touch on some of the advantages of a cloud computing platform over traditional HPCs. So share some of the reasons why this cloud-based method, I believe, is really going to be great as we move forward into larger scale analysis of biology-based data. And then finally, I'm going to briefly touch on what's next for Precision Fda and DNA Nexus. And I'll also throw out a plug for how, if you're interested in this, you can get involved, whether that's working with Precision Fda or if you have your own data sets that you're looking to analyze and you want to take advantage of some of these methods. So first off, what is DNA Nexus? This has come up a couple times. This is the company that I work for. In this slide, the biggest highlight here is DNA Nexus is a platform. This is a cloud bioinformatics platform really designed for discovery and analysis. This is a cloud platform where it has a graphical user interface. It has the ability to manage your data similar to Dropbox or Google Drive, and then also analyze your data. And this brings a number of advantages of working in the cloud onto to apply to your research. We're going to talk about those a little later in the talk. You're probably also wondering, who am I personally? So as Kristen mentioned, I'm Dr. Sam Westreich, PhD, PMP, all of the acronyms. I am a scientific program manager at DNA Nexus. So DNA Nexus is the company that helps host and manage Precision Fda. My background is microbiome bioinformatics. So I originally came into this working solely on microbiome and setting up pipelines for there. But since then, I've expanded as Precision Fda has expanded to cover more general use cases and a wide variety of different bioinformatics pipelines and applications. And as this talk will reveal, I'm the primary manager for Precision Fda. So I do a lot of work guiding future feature development, engagement with FDA users, and planning out future engagements that will help grow this platform. So first topic that I mentioned, creation and goals of Precision Fda. So if you ask, what is Precision Fda? If you go to precision.fda.gov, you get the lovely description that was written by a whole bunch of scientists and executives who are all sitting around, which is that it's a secure, collaborative, high-performance computing platform that builds a community of experts around the analysis of biological data sets in order to advance precision medicine. That's a mouthful, right? So you might be asking, okay, but really, when you put aside all of the jargon, what is Precision Fda? What it boils down to is this is a cloud bioinformatics platform. This is a platform on the internet where we're able to do bioinformatics, and it all runs on cloud servers. Cloud servers have often been described as just borrowing somebody else's computer, and that is the case here, but we're able to borrow a lot of other people's computers. So it has a lot of potential and a lot of abilities and features that you might not get on a traditional system. So this is a place where you can upload, download, and share files. where you can build executable code, which we refer to as apps, just like on an iPhone, and you can use those to help analyze those files that you bring to the platform. We host organized challenges, and I'll talk about a few of those in a minute. This also offers a place where tools can be shared with other users. So if you build executables that you think are great and you want to put them out into the community, this is a place to do so. And then those apps can also be combined into multi-stage workflows. So for somebody who has multiple stages of analysis, you're taking your raw FASTQ data, you need to do quality control, you need to annotate, you need to aggregate, you need to then analyze, you need to then put it into R and get some statistics out of it. All of that can be built into a workflow, which can be all run on this cloud bioinformatics platform. So this is all built on top of DNA Nexus. DNA Nexus is the company that provides this platform, and Precision FDA is one of these custom portals that we have. So this is a custom space that we built in collaboration with the FDA that is largely used by the FDA and its partners. For all of these portals, they work on top of base level of Amazon Web Services and or Microsoft Azure. So those are the computers on which all of this is running. But we bring our own computation services, data services, and management services on top of those instances. This means that it's a lot easier to work with these because you do not need to be a DevOps expert. You do not need to know how to work with cloud architecture. We handle all of that backstage stuff for you. So you just have to focus on analyzing your biology-focused data. So one of the big things about Precision FDA, one of the reasons why we built this, and one of the reasons why this platform is unique, is that this platform is FSMA and FedRAMP moderate authorized. So these are security rules that we have put in place. There is a lot of security that governs all of this, but this allows for confidential data to be provided on this platform and shared with the FDA without concerns about this data leaking or being accessible to others. This is really important because before this, the way that a company would submit their clinical data to the FDA is they would actually load it onto an external hard drive. They would go to their local post office, they'd put that hard drive in the mail, they mail it to the FDA, and then the FDA receives it, brings it into a secure room, plugs it into an air-gapped computer, checks it, and then sends an email back to the person who submitted the data that says either, yes, we got it and it looks good, or no, this data is incorrect. If the data is incorrect, the person doesn't even get their hard drive back. They don't get to be pointed out what's wrong with it. They'd have to go buy another hard drive. So that business was maybe good for Best Buy and US Postal Service, but less efficient and rapid when it comes to actually having rapid data transfer and a seamless integration. With Precision FDA, instead of needing to go through that whole physical process, here a user can simply upload their data to Precision FDA, which has this government security but is outside the government firewall, allowing for that data then to be looked at by the FDA, and the FDA can directly message the person back if there's any inconsistencies or issues with that data, and the person can simply re-upload to the Precision FDA platform. So we've cut a lot of the shuffling and a lot of the downtime out of this data transfer from corporate groups and industry groups to the FDA and then vice versa. So Precision FDA is used by a wide variety of various groups out there. This is just a screenshot that I actually took off of the Precision FDA site. As you can see, there are a lot of logos that we have. The main focus here is it's a range across industry and academia. Everybody from test providers to standards making bodies to pharma companies to healthcare providers to academic medical centers, consumers, and research consortia. So all these different groups are able to interact on Precision FDA, and many of them have used Precision FDA for either data exchange, data analysis, or other collaborative projects. This is the advantage of having this secure platform, is that we're able to foster collaboration between these different groups, and they can be confident that their data is protected. So that's what Precision FDA is. Now let's talk about what it does. What are the methods of FDA and community engagement? In other words, how do we get anybody to use this wonderful, lovely platform that we built? So one of the big things that we offer on Precision FDA are these hosted challenges. And for some of you, depending upon how involved in the bioinformatics challenge collaboration space you are, you may have even heard of some of these. So we offer a framework for community challenges. We help handle all of the busy work, the registration, participants actually making submissions, a method by which then experts and challenge organizers can view and grade those submissions, helping to get people involved. And then the site is open for all people to come and join and participate in those challenges. And these challenges get a good range of experts joining them and participating. We have industry groups, we have government groups, we have other academic groups that'll join, and they're pretty varied in what we cover. One of them that we ran recently, this one's back in 2021, actually during the pandemic, was tackling the challenge of food safety traceability. So this challenge was focused on the fact that we need to be able to trace our food through the supply chain. And this challenge, instead of us providing a data set, this was more of an open-ended question, and people provided proposals and submissions for potential methods by which we could better enable food safety through better traceability. And so this challenge was run in conjunction with a couple groups within the FDA, and then it helped spawn a number of different ideas that are being followed up on now. Another challenge we held back, this one was during 2020 when COVID was still new and scientists around the world were still working to try and understand it. We actually held an appathon where we encouraged participants to build their own executable tools on Precision FDA, their own apps that are useful for COVID prediction. And so for this, we provided a bunch of clinical data sets out to the public. And we said, build your own tools that are able to read through this data set and give us the best prediction of either who is likely to develop COVID, who's likely to see severe side effects, or which treatments might be most effective for different subgroups within this population that we're presenting. And so this ran, and we got a wide range of different tools, and we selected winners and the most popular tools that are applicable to COVID and then popularized those. Another challenge that we ran, this one actually, the Truth Challenge V2, this spawned off of the original Truth Challenge, which ran on Precision FDA about 3.5 years ago. And the original Truth Challenge focused on variant calling across the human genome. This was done in participation with NIST, the National Institute for Standards and Technology. They provided incredibly deep sequenced genomes from a trio, and they asked for participants to build the best variant calling algorithm and provide that. And this got a lot of attention from various groups. Google DeepMind was involved in this, and they actually placed very highly and won one of the categories. And then they bragged about it on all the slides afterward. I saw it was always, hey, we were a winner of the Precision FDA Truth Challenge. So we decided that we were going to revisit this challenge back in 2020, and this time we were going to focus on difficult to map regions. So once again, NIST provided the sequencing data, where this was deeply sequenced data looking at variable regions of the human genome, and we encourage participants to build their best variant callers and put them forward in order to determine the best tools that were currently out there on the market or in the business in order to use for variant calling, especially focusing on these regions. And this attracted a lot of attention. There were a whole bunch of industry groups that participated in it, but we also get participation from other groups, from academics and even from individuals who have either built a tool or are interested in getting into the space. Working with these challenges, anybody can participate in one of these challenges. They just need to sign up for a free Precision FDA account, and anybody is able to submit. And this puts a lot of valuable real-world data out there, where if you're looking for a data set to iterate on when you're working on some problem, this can be a source of it. So if you are interested in hosting or sponsoring a community challenge, please reach out to us. We can help guide and support you. These are free. We don't take any payment from you, so you're able to bring your own problems, and we have experts on our side who will work with you in order to help set up the challenge, write out the guidelines, handle all of the busy work of advertising and hosting the challenge for you. And you can get widespread community involvement for help solving a real-world problem that you may be facing. So that is a great way that we allow for engagement. Other ways that we encourage users to get into Precision FDA is also exploring data. Precision FDA offers a public files area, so any user can contribute references, resources, or other data sets, and anybody is able to publish a file to make it discoverable for all users. This is really useful if somebody is looking to publish a paper and you want to make sure that you have hosted files in a place where they will remain with a unique identifier that can always point to that file. That is all supported on Precision FDA. So a lot of folks will bring data onto the site and use this as a data management service. We also allow for analysis. So again, we're talking about all the different ways that we get people to come and join Precision FDA and put it to use. One of the big ways that people get drawn to Precision FDA is because they have data and they need to analyze it. So this is a cloud-based bioinformatics platform, as I've said a couple times before, where we have apps, which are programs or tools, and workflows are linked apps put together. And along with being able to build your own apps, we have a wide range of public apps, and those apps that you build can be shared with other users. So app creation is available for any user who signs up. You don't need any special license in order to be able to take some code that you've written and turn that into an executable tool on Precision FDA. You even don't need to know a lot about code or command line. We don't have a complicated build process. All of the app creation is handled through a web UI. So we actually guide you through setting up the environment. What amount of resources do you need? How many gigabytes do you recommend that this tool should have for RAM and for storage? What are the inputs? What are the outputs? And then what is the actual code that should be executed? And so we walk any user through setting this up. So when you create this, you're not presented with just a command line prompt and you have to deal with all of that yourself. All tools that are built on this platform are private until the creator chooses to share them. So if you have a tool that you want to put out to the community, but you're not certain if it'll work properly on the site, any iteration of this that you build is going to remain private until you say, I'm ready to make this public. I'm ready to share this with the wider world. And then these apps can run pretty much any code. They're all running on virtual machines that support Linux. They're all running in an Ubuntu environment. So this means pretty much any tool that you pull off of GitHub, it can run on this. You can access the internet from these. So if you need to download data or you want to have a tool that pulls in a public reference data set from someplace online, you can have it do that. And there are very few limits in terms of really what tools you can bring and turn into an app on Precision FDA. And then we offer a wide range of instance sizes. So this is one of those big advantages of working in the cloud, right? Nobody needs to go plug another stick of RAM into a local computer. On here, if you need a larger instance, we just get a larger instance as a virtual machine from Amazon Web Services. So this can scale up to 600 gigabytes of RAM and 2.4 terabytes of disk space, which is enough for most tools. One of the tools actually that we're looking at implementing, which is presenting a couple challenges right now, inside is AlphaFold, which is from Google, where that one requires GPUs, and it also requires something like 2 terabytes of RAM in order to run properly. So we're working on scaling up to the point where we can even support AlphaFold. But for most bioinformatics applications, if you're doing annotation or you're doing variant calling, 600 gigabytes of RAM should get you there pretty well. And so that's going to be miles better than what you'll get on your local computer if you're trying to do this locally. And this also won't have an HPC administrator scream at you or that you are hogging 100% of the resources. Once again, advantages to cloud. As I mentioned, there are a whole bunch of tools on Precision FDA. We have over 100. In fact, as of me taking the screenshot, I think 3 days ago, we're at 145 public tools that are available to use. These are in a wide range of categories. Everything from immunology to quality control to variant calling to RNA-seq-based tools. And again, we're constantly adding more. So you can find tools that will do pretty much any task on here. And because we're adding more, we're open to suggestions of other tools that we should put on here that we may not have heard about. And so we do this. The main focus of this is to support FDA reviewers as they are analyzing data sets that are submitted to them, but we also make sure that we incorporate tools in order to have a balanced range of tools that cover different areas of focus for various topics of research. And then finally, workflows is just a way to string tools together. So just like for building an individual tool, this can be done through a web UI, and so you don't need to go all the way to the command line. Connecting workflows to each other can also be done through this graphical interface. So just like you can build any number of apps, you can have any number of workflows. You can always customize those workflows and take them apart and put them together. And as you can see from this diagram, it's a lot like Legos or other building blocks where you add in the tools that you want to use, and then you can draw lines to connect the outputs from one tool to be the inputs for the next stage, if this is what you're choosing. And just like with tools, the workflows can be made public, and you can share these with others if you have a workflow that is useful and you want to share it with collaborators. So for sharing all of this data, Everything that you bring onto Precision FDA is going to be private by default, but we also offer shared areas, which we call spaces. So if you are working with other collaborators, this is a great way to be able to bring your data on and then put it in one place where all of those collaborators are able to access it. And all of this is then managed through Precision FDA. So all of the data is localized. It's all available. You can control the membership. So you can always add or remove collaborators from access to that space. And just like there's no limits on the number of apps, no limits on the number of workflows, there's no limits on how many total spaces you can be involved in. And then the last thing that I just want to highlight here is collaborative review spaces. So this is one of the ways that the FDA is using this Precision FDA platform. We have FDA reviewers that set up these collaborative review spaces with industry partners. With this collaborative review space, each group has their own side where it's private to their side where they can stage data and tools. And then there is a central shared area where they're able to place any data that is being shared among both groups. So on here, the industry reviewers have their own space where they can place any relevant data and tools that they're using for their submission to the FDA. The FDA reviewers can have test data and perhaps an answer key that they place on their side. And then in this shared area that's accessible to both groups, reviewers are able to say, here's a test data set in order to analyze. And then the industry, a sponsor, can take that test data set, can analyze it, and provide the results back into this shared central area for the reviewers to bring over to their side and check to see how accurate it is. And so all of this is one FedRAMP moderate protected space, which can then be saved and can be archived at a later point. So there's always a record for any review that happens between an industry sponsor and FDA reviewer of exactly what was done, what data was provided, and what the results were. So all of this can be collected and stored in one place, and all of this review can take place on one platform, which is a big selling point for Precision FDA within the FDA and for the federal organizations that perform these reviews. So that was the different methods that the FDA and Precision FDA use for community engagement. Now, I just want to touch on cloud computing platform versus HPCs. So this was really a big push in Precision FDA and also for DNA Nexus. This is one of the big reasons why we are around, AKA, why learn a new cloud-based system? And for many folks who have been working with HPCs, working with analyzing data on local computers, it can be tough to switch over to working with a new system, especially adapting to cloud. But there really are some advantages to this. And I just wanted to touch on a few of these to help introduce, why you should consider looking at cloud for a future analysis. So first one, again, is Precision FDA and DNA Nexus. This really is a Dropbox where there are very few limits placed on what you can do. So again, you can share data that you bring to this with anyone. As long as somebody has an account, they're able to access that data directly. So unlike if you're putting data on an HPC or if the data is on a local machine, here, anybody can get access to that data if you choose to grant them access, as long as they have an account. And there's no need to wait for data transfer or to deal with long upload or move times. Once the data is in the cloud, it's accessible to everyone. Another big advantage here is there's no file size limit. I cannot tell you the number of times where I was working during grad school and all of a sudden my computer would stop and I'd do a df-h and it turns out that I'd been unzipping a really big FASTQ file and just completely filled my hard drive. And it's like, there's no space. You can't do anything. It wouldn't even auto-complete. And so one of the great things since moving to the cloud is no file size limits. I can bring data on that's pretty much any size and it's handled totally fine. And so on here on Precision FDA, we have had tens of terabytes of data for a single data set that people have brought onto the site, and it still works at the same speed as before. So this doesn't even slow it down. You're able to bring, files that are hundreds of gigabytes. You're able to bring data sets that scale into tens or even hundreds of terabytes, and the cloud is able to expand to cover that. I talked about FedRAMP before, this idea that this data on here is protected and secure, which enables the use of confidential data, confidential unclassified information, PHI, PII can be brought onto this platform and can be stored on here. And it's all been authenticated and we maintain that FedRAMP certification in order to make sure that that data remains secure. And then one of the other great things about working in the cloud is just that everything is tracked. So this is really great because for any data that you have on Precision FDA or on DNA Nexus, we track all of the provenance for that data set. So you can take a look at a particular file and you can see, when was this file first brought onto this platform? Was this file generated from a tool? If it was generated from a tool, how was it generated? What were the parameters of that run? What were the other inputs? When was that execution performed? All of that is trapped. So this is really great if you are working with a large set of files, or you're working with an experiment that takes place over multiple weeks, months, years, and you want to be able to record what happened, what you did, and make sure that for any particular set of results, you can go back and trace the provenance of that. That is all supported by Precision Fda and the DNA Nexus Cloud platform. And then the other great thing, I talked about data being secure. One of the concerns, I think, with working with the cloud is the idea that I'm putting my data out there, right? It's going out and it's on somebody else's server and I can't see it and I don't want it to get leaked. I don't want this data to be shared with others. On Precision Fda and on DNA Nexus, any data that you bring on is private by default. It cannot be viewed by anyone else. That includes even the site admins who manage the site. They're not able to go in and access the data that you upload into your private area. Everything stays private by default until you choose to share it. And for getting that data onto Precision Fda, we have a number of different methods. If it's small files, you can upload through the UI from your computer. We also have a command line upload tool, which is really useful if you're working with very large files or you're in a place where the data stream may be interrupted. This uploader can resume a partial upload. So if you're transferring a 100 gigabyte file and then the internet cuts out when it's 90 gigs transferred, this way you don't have to start all over. You can just resume and that file transfers completely. And this can also be run on HPC environments. You're able to use this from any command line interface. So you don't need to have a desktop. You don't need to go through a graphical interface in order to bring data onto Precision Fda. And then the last thing we can always do is, because this is the cloud, we can grab things from anywhere else on the internet. So I have worked in demonstrations. I've used a lot of sample data that's come out of RefSeq or Gene Expression Omnibus. And all I need is the URL where that data is stored, and I can import that into Precision Fda to pull those files into my cloud environment. So a number of different ways to get data onto Precision Fda or DNA Nexus from wherever it might be hosted currently. And then once it's on there, as I've talked about already, we have all these different tools that are able to analyze this data. A big advantage of working in the cloud is that those tools can all run in parallel. And this is something that when I first joined this company, I had come here from doing my PhD, where I remember working with our university's HPC, and I remember submitting a job and being like, all right, I'm done for the day. I get to go home because that job will not be finished. It's in the queue. It will not be processed until tomorrow at the earliest. On Precision Fda and DNA Nexus, the good news, bad news. The bad news is that you cannot go home for the day because you're waiting for your jobs in a queue. The good news is, thanks to parallelization, everything runs at the same time. Instead of needing to wait for a worker to become available, with these platforms, we simply scale the number of workers. So we have run, I think the grand total is a couple million workers at once on various jobs coming from various customers. So we can scale up where if you are bringing a lot of data, all of that data needs to be processed independently. We can run all of those jobs in parallel. And I have done this where on Precision Fda, I have kicked off 150 jobs all at once. I had 150 files. I said, I want to run, Trim-O-Matic on all these files. I am going to hit run, and it's a batch mode. And with one click, I set up Trim-O-Matic to run on all 150 of these files, and they all started at the same time. And I only had to wait for the largest single file to finish. So as soon as the longest single job is done, everything is done. And this is really great because if you're working with a ton of data, you can even specify different inputs, different parameters when you're running these in batch mode, and everything starts at the same time. I don't think I can emphasize this enough, how amazing this is to go from working on a system that is resource limited to working on a cloud platform where you're able to scale for however much data you're bringing in, however many executions you need to run. You can support all of these working at once. So I've talked a bit about now creation and goals of Precision Fda, talked about the methods, I've talked about the advantages of working in the cloud, and the last thing I want to touch on is what is next. So Precision Fda has been around now for 5 years, actually 6 years now because it's 2022. I always forget what year it is. And we have continued to grow. This started off as a small research project within the FDA. It is now a fully productionalized platform. It has been in production for 3 years. It'll be 4 years in September. And we're continuing to grow and add new features. So when this was first conceived, oh my God, it's 2015. This was 7 years. This just shows how time flies and how I am bad at doing math when it comes to years. Precision FDA, when it was first conceived in 2015, it was really just about regulating genomics data. The idea was that we were going to support next generation sequencing and allow for those files to be stored on the cloud and for there to be basic tools that could be applied to that genomics data. In the last year to 2 years, we've really expanded on that basis of genomics, and we're now offering tools that are able to touch on data sets from a wide variety of different omics areas, microbiomics, proteomics, transcriptomics. You can see the whole list here. The idea is that because these platforms are data agnostic, we can bring any type of data onto this platform as long as it's in files. We can analyze that data with pretty much any tool as long as it runs in a Linux environment. So this means that you can bring genomics data onto the platform and analyze it with the genomics tools that are available. And then if you have paired proteomics or transcriptomic data, you can bring that onto the platform as well and analyze that with the tools that are there as well. So there's no limit on the types of data that can come on, and we're able to find tools and build tools that are able to handle these different omes in order to analyze them and then eventually effectively combine them. And so for this vision, we have been continuing to connect to additional data sets and resources as well. A couple that I want to highlight that we've added in the last year. The first one is GSRS. For those unfamiliar with it, GSRS is the Global Substance Registration Service. So this is a data set with every substance that is used in various medicines, biologics, any sort of data, any sort of substance that needs to be tracked. And so the GSRS team is a group at the FDA that maintains this database of all substances and also handles tracking and registration of these substances. This means that if you discover a new molecular compound and you want to register this, which you'll need to do if you then want to reference it in a patent application or in a biologics application or some use case that you want to put forward and you want to be able to reference specifically your unique compound, you register it in the GSRS. And that database is also accessible to be searched. So if you are looking for a specific compound, you can look it up and you can get its unique accession ID, which you can reference in publications, in grant submissions, in any sort of paper where you need to make very clear exactly what substance you're talking about. So we actually incorporated that database onto Precision FDA, and Precision FDA users are able to access the Global Substance Registration System, search for substances, create their own submissions, and build that submission to then submit to the GSRS team at the FDA so it can be added to this database. And so this is a new way to get your substances into the records so that they are recorded, and you can then use that for future applications. The other tool that we're working on adding now is this common data model for harmonization. This is a tool set that focuses on clinical queries. One of the challenges with querying clinical data is that this clinical data tends to be stored in a wide range of formats, and various medical centers have chosen different formats by which they want to store their clinical data. With this common data model for harmonization, a single data query can actually be translated into the appropriate query type for various different clinical record storage systems. Those storage systems can be queried, and then all of those results can be aggregated into one format. So this is really harmonizing across different clinical data storage formats. So with this tool, what we hope to open up is that FDA users will be able to write a single query to say, I want to find patients who are female, over 55, and have a history of breast cancer. And they can send out this query to multiple medical partners, each of whom stores their data in its own format, but they're able to have the single query search across all those formats and bring back results, which are all aggregated and placed in a single format for that researcher to use. So this is in conjunction with NCATS and the FDA. They are the groups that help design this model. And through Precision FDA, we're able to forge this connection so that researchers can get to that data and then bring it onto this cloud environment in order to be analyzed. So in summary, cloud computing really is helping the FDA advance, and that has been our goal with Precision Fda. The idea is that we offer this FedRAMP secure cloud bioinformatics platform. This was originally built for FDA reviewers and industry sponsors, but it's open to a wider audience, and we encourage others to join and help develop and grow this platform. There is a community here, and one of the goals of community is to grow and to support its various members. And so any participation on Precision Fda, whether that's bringing on challenge data or helping to host a challenge, helps the community and brings new members in and may unlock new tools and new data sets that can be available for others to access. Building tools on Precision Fda makes more resources available. And additionally, if you are a tool developer or a tool builder, putting it on Precision Fda can help get it in front of an audience who can then make use of that. And then if you have public data sets that you want to share, bringing those onto Precision Fda improves the richness of what we offer and provides more resources for community members to join. Additionally, if you're going the other way and you're looking for data, Precision Fda can offer a valuable trove of open world, real world data that you can then make use of because it has been shared publicly on the site. Another advantage of Precision Fda really is this cloud interface. We want to help take the challenges of tool development, move all of those to an online environment where you're able to get a lot of the advantages of cloud. You're able to get that near infinite job scaling. You're able to get that unlimited data storage where you never have to worry about unzipping a giant FASTQ file and breaking your local laptop ever again because it all works in that cloud environment. And you're able to also handle sharing. You're able to bring data sets onto this platform and use its spaces function in order to share that data with partners without ever needing to go back to the old days of having to mail a hard drive or having to, deal with a file sharing site with limits. With Precision Fda, with these cloud platforms, they're really built around sharing data without limits, especially when it comes to biological data, which can scale very large and can get really big and really unwieldy if you don't have an approach like this. And so our ongoing development is always in progress. Precision Fda is continuing to grow. We have at least 2 more years where we're going to be in production. And then after that, we anticipate further expansions. In those 2 years, we are constantly developing new features. We're bringing in additional data sources, expanding the tool library. And we're also adding new features for just ease of use and access to the cloud. So for various groups that engage with us, not only are we adding new features, but we're constantly updating and maintaining the features that we do have. So better app development, access to interactive workstations that allow for user input when you're running tools, graphical tools. So if somebody is looking to run tools like RStudio, where it brings up a graphical user interface, or Jupyter Notebooks, where it brings up a graphical interface, we're working to support those. There's a lot of power and a lot of capabilities here that we want to open up to pretty much everyone. So with that, I am ending a little early, but I think this leaves time for questions. If you have questions, you can either put them in the chat, or if you are listening to this talk later on as a recording, please feel free to reach out to our support line. If you have a question about working with Precision Fda, you can reach out directly to me. Here is my email, which I am putting out on the internet. So anybody who has any question about whether it's working with Precision Fda, working with DNA Nexus, or bringing on any sort of data set, getting involved in challenges, please feel free, shoot me an email, and I will work to help you out, or at least direct you to the appropriate resources so that you can get your question answered. I definitely invite you to check out Precision Fda. You can see the URL right there, precision.fda.gov. And then finally, if you are interested in doing more general purpose cloud analysis of biology-based data, consider our more general purpose platform, which is DNAnexus.com. We have a whole bunch of white papers that explain how we can use this platform for various uses. We, again, offer a wide range of tools, and we also offer a white glove bioinformatics support. So if you are looking to build a project or analyze a bunch of data and you are new to the cloud and you want assistance with getting set up, you can work with us, and we have bioinformaticians that can help you out with analyzing your data, building the tools you need, or overcoming whatever challenges you might encounter as you're moving into this cloud environment. And so with that, I am all wrapped up. So I'm going to stop there, and we will see if there are any questions or comments.
Excellent. Thank you so much, Sam. It seems like the capabilities that you've built out with the FDA have really advanced their capabilities, and really that affects all of us, because being able to accelerate clinical trials, being able to have better collaboration around these data types, it makes all of these health advances much more expeditious and efficient, and we most certainly need that, and I'm sure the pandemic has even underlined that to a greater extent.
Yes, definitely. This has
Yeah.
talking with some of the reviewers, they talk about the old methods that they used to use before this, and they have pointed out that this has been a considerable increase in the speed and ease of access in working with collaborators and sponsors. And so that's really been our primary drive, is to make that run smoother. But then, we want to make sure that we support this community. And so we're always looking for new tools and new challenges that we can use to help grow this and support the community. Yeah. I do see that there is a question. That question is, if I was making a custom script, basically a Perl one-liner that only needed to be run once, but I found out that it could be used again, is there a history of commands that I could look through? Could those then be made public? So there are a couple options here. You could build a really simple app that just runs that Perl script, or what you could do is Precision FDA also supports shared or public notes. So you could always have a note where you record useful one-line commands, and you could publish that note. You also asked perusing others' code snippets in order to run on my own data. Yes, that is something that we fully support. In fact, any tool that is built on Precision FDA, when it is shared with others, we have it shared open source. So for all of those public tools that we have on Precision FDA, all 145 of those, you're able to take any of those tools and you can actually fork them to make your own customized version. And that forking also allows you to see a code of how that tool runs. So if there's a tool that's running, we actually had somebody write to me recently about this, where we have a tool that's running a GA4GH comparator. And this person said, we're trying to get GA4GH working on our own systems, and we're not really sure how to set it up. And I said, yes, hey, why don't you just take this tool that we have publicly on Precision FDA, fork it to make your own version, and you can look at all the code that is running for that. I will say, if you have code that you want to remain proprietary, you can always compile that into an executable, attach that executable to the tool as an asset, and that way that code will stay opaque. But for most of the tools that are on Precision FDA, they're running public tools. They're running tools that you can find the source code on GitHub or other places. And what we show and what you can explore by forking it is, how is that tool set up? What are the parameters in order to run it? What's the command look like in order to run it? What are the inputs and outputs that are generated by it? What are the flags that are given? All of that is saved for these tools. And so you can take any public tool, fork it, and take a look at how it was put together. And so similarly, if you built your own commands, you can then build those as a very simple little app or tool. You could make that public as long as you describe, what it does, and then others could access that, and they could either run it directly the way that you set it up, or they could fork it and they could customize it for their own uses.
Excellent.
Dr. Murray, hopefully that answers your question. If you have more specific ones, feel free to shoot me an email and I can assist with that.
And it looks like Dr. Murray also asked, is there a preferred coding language as well too? Is there anything else you want to add on that?
Oh,
and I guess one question I had too.
Down, I did not realize to scroll down and there were more questions.
There you go, yeah.
So for preferred coding language, there is not really any preferred coding language. Again, as I said, all of the cloud instances that run when you launch a worker, they're all running Ubuntu. I think the current version is 16.04. We're adding support for 18.04 now. And so as long as it runs in a Linux environment, it will run on one of these instances for Precision FDA. They come with a Python 2 and Python 3 and R, I think R 3.5 installed by default on them. Keep in mind, for anybody watching this at a later date, those may change if we upgrade and we support later versions. So don't take those for certain, but you can always check on the instance just by saying, R version and see what it is. If you are using a more unique language, you may have to install that. But again, one of the great things is, because these run on virtual machines, you're able to run pretty much any command. So you can install various other packages. You can install other programming languages. You can have an app where the first thing it does is it installs Anaconda, and then it uses the Anaconda package manager in order to pull on a bunch of different packages that are used for the app it's going to run, the tool it's going to execute, and all that is supported. And because these run on cloud instances where it starts a new instance every time you run it, this means you don't have to worry about messing up your environment. Every time you run one of these, it will install whatever you specify, but when you're done, it shuts down everything. And when you start again, you get a fresh environment.
Excellent. One question I had tying into the community growth and supporting their efforts, how do you manage the different interests and feature requests from all of the users on Precision FDA and then also from the FDA itself?
That is a great question, and that has been ongoing work has gone into that. So our primary users are FDA users. The primary purpose of Precision FDA is to support FDA reviewers as they engage in clinical reviews with various sponsors. So our main focus, our number one focus is, of course, those reviewers. But then beyond that, we generally make sure that we focus on the other groups. Every year in our contract, when we specify what task order items and upgrades we're going to add onto the platform, we make sure that we pick some to support various different members. So instead of focusing solely on one group, we try and support them all. We also have, there is a discussion forum on Precision FDA where users can post questions. And so if somebody has a question, it doesn't necessarily need to come directly to DNA Nexus as the central hub, but instead can be answered by other users. So users are able to post questions about, hey, how do you get a tool to do this? Are there any programs that support this capability? I'm looking to set up a program and I'm running into this error. Is there any support? And so other users can help provide that assistance as well. The challenges I'll also mention are all sponsored and supported by the FDA. So any challenge that runs on Precision FDA is organized in conjunction with the FDA and has their underwriting and support. So there's actually a challenge coordinator on the FDA side who helps with setting those up and engaging with collaborators who may want to help host or design or sponsor a challenge in order to make sure that it goes smoothly. So there's a significant FDA involvement as well, and they are invested in making sure that Precision FDA is a success in these multiple different areas.
Excellent. Okay, thank you. It looks like we have another question coming in, and it reads, how do you protect against bots abusing your cloud to be a junk repository or using a VM as a Bitcoin farm, for example?
So this is something that we have tackled. So on Precision FDA, when users register, there's actually an approval step that the FDA holds, and FDA admins are able to monitor usage and restrict users or cut them off if they're using too much and can disable accounts. So for Precision FDA, you cannot automate the sign up because there is a manual approval step that we perform on our side. And what you do specifically is private, but we're able to see the usage on the platform. So we are not going to be able to peer into your private area and look at exactly what your code is because there are IP concerns and we don't want to do that. But if a new account appears on Precision FDA, even if it gets approved, if we're like, okay, this account is now running 100 jobs 24/7, and those jobs seem to just keep going, we are going to reach out to that individual and we can disable that account if necessary. On DNA Nexus, you are able to sign up on DNA Nexus and you get many of these same features without needing to go through that approval step. But we do constantly monitor who signs up to make sure that they are real people and not auto-generated email addresses. And we also track the usage, and we have some flags that check for some of the most popular miners to block that. In terms of abusing the cloud to be a junk repository, again, on Precision FDA, admins are able to manage and clean up the public data. So if there is, if somebody posts something as a public file that should not be there, admins are able to go in and remove it. On the DNA Nexus platform, actually, the idea of fully public data doesn't exist, and it's only what you share with others. There certainly are some industry groups that will use DNA Nexus, the DNA Nexus cloud platform, as a repository. And that is something that's supported. You know, I've mentioned multiple times that this is data type agnostic. So if you just have a need for, I need a place to host a bunch of data, I need a place that is centralized, cloud accessible, and doesn't have storage limits, that's a valid use for the DNA Nexus platform. You know, not everything necessarily has to be specifically for biology or data that you're about to analyze. Seth, hopefully that answered your question.
Thank you. Excellent. I think we have time for maybe one or two more questions. I had one that can always be a plaguing issue in computational biology. But when you're talking about these very large parallelized runs, hundreds and hundreds of samples, what kind of mechanisms do you have for error catching to be able to triage these if it's a one-off type of an error or if you have a systematic error, especially when it's in the middle of a pipeline, for example?
Yeah, that is a great question. So that's definitely an issue that comes up, and especially if you are, as you said, running a multi-stage pipeline, it's really terrible when, you know, it fails at stage 5 and you're like, no, all of my work. So there's a few solutions that we have. The first one is that because you can break apart a multi-stage workflow into different apps that are chained together, each app, when it finishes, will have its own outputs. So this means that even if a workflow fails overall, if it made it to step 5, steps 1 through 4 did complete successfully. And so you have the outputs up to step 4, which you can then use to restart step 5 after making corrections. On the DNA Nexus cloud platform, we even have something called Smart Reuse, where if you have to restart a job, it actually saves the progress. And so it will resume partway through. So this is really useful if you are running one of these giant workflows. If you have a failure, you can restart it. And our platform is smart enough to say, I see that these exact files went into stage 1. And so I can skip stage 1 because I already have the output from it. These exact same files went into stage 2. I can skip stage 2 because that ran successfully and I have the output from it. And so this way you're able to, even though you start the whole workflow over, if you watch what the platform actually does, it actually jumps right to stage 5, which is the step that failed previously. And so it's able to restart there. The other component is for if you launch a bunch of data through an app and it's all in parallelized runs, if one of those fails, you can always pull up the individual run by run jobs. And so you can then always go back and you can see, okay, I launched 150 jobs, 145 of them finished successfully, 5 of them failed. Here are the 5 failed runs and which specific files were going into each of those runs. So that way you can then do spot triage and go back and say, okay, I'm going to rerun just these 5 instead of needing to grab all 150 and throw them in again.
Excellent. That sounds like a great way to reduce all of the headaches that come with that and parsing messy log files and everything. That's great.
Yes. You also can view all of the logs for any particular execution. So for people who do really like to get into the nitty gritty and dive into the logs and be like, I want to see exactly what the error message is and exactly when it failed, all of that is accessible as well. You're able to get all the way down to the individual log data for every single execution that runs. Excellent.
Excellent. And I don't see any more questions in the chat, so I'll ask one final question. And it's a two-parter, I suppose. 1, do you take interns? And 2, could you tell a little bit about what it's like working at DNA Nexus for people who may be considering applying or that type of a field for their once they graduate, for that type of thing?
Yeah. I'm actually, hold on, I'm going to go to this previous slide because I'm getting distracted by the big spinny question mark.
Shiny objects.
So yes, we do take interns. DNA Nexus has a number of intern offerings every summer focused on a range of different groups. It's everything from biologists and bioinformaticians to data scientists, platform engineers, DevOps folks, front-end or back-end computer science folks. So we post all of those intern offerings online, both on our DNA Nexus website, dnanexus.com. Then we also post them on a number of common job sites like Indeed, Glassdoor, other places like that. So you can go look us up and find those openings if you are looking for an internship or you know somebody who is looking for an internship. Generally, we do them during the summer. but you can also, we are not a huge company. Right now, we're about 200 people. So that is small enough where you can potentially reach out to us if you have a particular skill set or a particular need, and we can engage with you directly. It's not going to get lost in a giant shuffle. As far as working at a tech company especially a tech company in Silicon Valley, Bay Area, it is a unique and busy experience. I will say, I've always been in the Bay Area for my career, and so there is a ton of discussion groups and collaboration that happens here. There are semi-regular meetups that happen here between various different biology-focused industry groups. And so I've been to some where there are talks where, PacBio will put on a talk, and there's people from 50 different startups and biological-focused companies that show up and join and mill about, and you can make a lot of connections, and there's a lot of discussion, which is really great. The work here, it's very fast-paced. One of the things about working in industry versus academia is we have a lot of problems that come in that are things that need to be jumped on right away, but that is often more fun because then you no longer have to wait on anybody. Everybody is immediately interested in seeing something progress. And so, we engage
all hands on deck kind of a thing.
Yeah, we engage with a wide range of customers. Every customer has a different problem that they bring. No two problems are ever the same. And so it's a lot of fun. Every week it's new challenges, but I think those are exciting challenges, and they are incredibly applicable to the forefront of research that's happening today.